Hello and welcome to a very spooky episode of Cascadia Mountain Weather right before Halloween this year. This is a satellite imagery from today, and Washington was a bit cloudy, but you can see that the mountains of BC are very snowy, and we're off to a great start for this winter. So we were thinking of doing something a little differently this week, and kind of asking the question like, well, one, how is our early season snowpack compared to normal? And are there any trends in early season snowpack? And Wyatt has crunched the numbers and he's gonna tell us what's happening.
Yeah. So we'll start out with like looking at our basin equivalent snow depths, or this is our snow water equivalent. So basically, if you basically drilled a core down your snow depth all the way to the bottom, and then you melted it all, how much water would you get? And generally that's recorded in inches. We'll see that in a second. But we're looking at the basins and seeing that everything is significantly above normal, above this 150%. That's mostly because it's early season and we normally don't see that much snowfall in the end of October. We can zoom into one of these stations as we do so frequently on these kind of episodes or these weekly blogs. And I want to specifically look at Hearts Pass. So this is up in the far northeastern Cascades. It's one of our highest stations that measures this snow water equivalent, the snowpack, as the year goes on. And so we can look at Hearts Pass, and this shows our progress over time. So if we look at this curve right here, this red line suggests like where is the minimum that it's ever recorded. And a lot of these stations actually are getting pretty old now. So they have anywhere from 30 to 40 years of record. So we're starting to get a pretty smooth curve of what our snow water equivalent or our snowpack might look like as we go through each year and what we might expect to see. Now, this black line over here is where we are currently. And we can see that we're at about 5.7 inches of snow water equivalent at Hearts Pass, which is maybe on the order of about 15 to 20 inches of snow depth up there. And it's actually quite a bit above normal. We can turn on our controls, or sorry, our, let's see, here we go. We can see that we're in the 95th percentile. So that's pretty good for Hearts Pass. What I was interested in is there a trend? So since we have so many years of data, if we look at all these different years, so I can turn on, for example, what did 1990 look like? Well, 1990 looked like it had an early peak and then kind of dropped off, but then held on going till kind of July when it melted out. And I wanted to look at a bunch of different years, and specifically, I decided to look at 7 different stations in the Cascades across a wide variety of elevation ranges. So, some of our lowest snow tell sites where we measure snow depth, about 3,000 feet, up to our highest, about 6,500 feet, and from kind of up near the border down to, or the Canadian border, down to the Washington border. So, I looked at these 7 sites, and let's first look at Hearts Pass, which we were just looking at. So this is the basically the date that we reached 25% of our normal deepest snowpack or snow water equivalent. If we jump back to Hearts Pass right here, normally we reach about 47 inches of snow water equivalent. Once again, if you melted that all down, you'd get almost 4 feet of water. And that would be equivalent to maybe 100 inches of snow depth. And that's the median max value around April 26th. I wanted to look at kind of when we get to a quarter of that value. I felt like that was a good measure of early season snowpack. And almost every single year that we have measured, even the worst year on record, which for a lot of stations was 2015. Well, not 2015 out here, but 2005 as well. We can see that 2005 is right near the bottom, got to that 25th percentile or 25th percent kind of benchmark. So 25% of 47 inches is going to be around 11 or 12 inches. So we can look at when that average happens, and that is right around December, maybe December 1st, December 2nd, right in that boundary. So going back to this graph, this shows every single date that we've hit that 25th percentile of kind of our normal max value. And you can see that we've had that bad year. So like 2005, it didn't happen until kind of mid January when normal is early December. Um, but if we look over time over the last 30 years, there really hasn't been that much of a change. So our line, our linear regression line is almost exactly flat. So at least at Hearts Pass, it hasn't changed that much. basically, if you went back to the mid 90s, you'd expect it to kind of hit in early December. If you went to today, you'd also expect to hit that snow depth, at least at Harts Pass in early December. If we go to Lyman Lake, which is just kind of south of Harts Pass in the North Cascades, still similar climate area, we actually see a different trend. We see an increasing trend where the date is gradually shifting later. Now, if we look at our R squared value, which is a measure of variance or how much kind of all of these points moving around actually correspond to our trend in years, getting later in years, it's not very high, which suggests that this doesn't really kind of correspond with as much variance. There's just a lot more variance from like year to year meteorological, oh, we have an El Nino or La Nina or this or that. But we do see that there does seem to be a bit of a trend where on average, each year you'd expect it kind of this 25th percentile date to move about half a day, or for 10 years, you'd expect it to move 5 days. But this was the strongest trend I noticed of any of the stations. So if we can put all of our stations together, here's all seven of them right here. This is all the data combined, and this is almost like a residuals plot, getting back into statistics, if you really want to go there. But this is like if every single date fell exactly when we expected it to, every single year that happened, we'd have just a bunch of zeros right here. But obviously, there's variability, and there's some years like 2005 where there's really, really bad snowpack, and some of our snow stations don't end up hitting their 25% of normal until like April. All right, so that's kind of where our snowpack peaks at. We can clarify this a little bit by smushing all of our data down together and just looking at it in terms of basically by year. And so if we look at this and combining all of our stations together, we do see that there's a slight upward trend, meaning that it does seem that like maybe every 10 years we're getting a day or two later for when we'd expect kind of our snowpack to get that 25th percentile. Um, but it is not a super clear trend. And I think we really would need to see like another maybe 10, 20, even 30 years of data before we could really establish this as a trend. But I thought it was just kind of interesting to look at and notice that, especially in like the 90s, we had some more of these really early years, and even in the early 2000s. But recently, we haven't had any of those really early years. Now, who knows? This year could be one of those years. But I think our weather this weekend is actually going to maybe prevent that from happening. But I'll turn it over to Kyle to kind of talk about that.
Thanks for such a detailed analysis, Wyatt. So now we're just going to go back and look at the weekend weather. So this weekend, we're going to have a system moving in later in the day on Friday, bringing pretty widespread precipitation during trick or treat and Halloween hour on Friday evening, unfortunately. It'll be moderately rainy into Saturday and then probably more showery in nature as we go into Sunday, especially in the Olympics and North Cascades. So now we're going to look at the 3 hour precipitation amounts. So as we go into Friday evening, this is where the heavy rain really starts. This is 8 p.m. Friday, and we're seeing, half an inch in the last 3 hours. That's pretty substantial. Going into Saturday, it's still pretty decent rain, but by Saturday evening, afternoon, it's definitely drying out in the lowlands and becoming more showery in nature. And on Sunday, there's virtually no precipitation in the lowlands in the Southern Cascades, and it's mostly confined to the Olympics and the North Cascades. This is looking at accumulated rainfall. And so by the end of the weekend, we will have quite a bit of rainfall. So we're looking at probably 2 to 3 inches across the Olympics, North Cascades, but a little bit less towards the Southern Cascades, areas in the rain shadow, and obviously the east side. This shows the temperatures at 850 millibars height, so it's a little bit, a few thousand feet up in the atmosphere. And this gives you a good idea of like how the precipitation is going to fall. So the red means it's warmer than normal for this time of year. And you can see that those warmer than normal temperatures persist through most of Saturday before finally cooler than normal air hits us late Saturday into Sunday. So the freezing levels reflect this. We're going to have freezing levels around 10,000 feet, 8 to 10,000 feet on Saturday, during when most of the precipitation arrives. So most of it's going to fall as rain, unfortunately. When the freezing levels finally do come down Saturday evening, there won't actually be that much more precipitation afterwards. So, we will see some light snow above 5,000 feet, but it's still going to mostly fall as rain for that, 4 to 6, 7,000 foot elevation band that most of our mountains sit at. This is snowfall in 3 hour increments. So, what basically on Saturday, there's going to be very limited snowfall. It's only going to be the volcanoes and maybe the high North Cascades. As we get on into Saturday evening, it gets a little bit better, but again, the precipitation amounts are pretty light. And so we might see some snow showers going into Sunday. The total accumulated snowfall is going to be pretty modest. So the higher areas in the North Cascades might get, 4 to 6 inches of snowfall, but that comes on the heels of an inch or two of rain. So we might actually see a decrease in the snowpack. In terms of snow water equivalent, we might actually lose snow water equivalent at a lot of places around 5,000 feet or so. Probably only the volcanoes will see a net positive out of all this. So for cloud cover, it's going to be pretty cloudy through a lot of Saturday, but might start to clear out in the evening on Saturday. And then definitely Sunday will be pretty sunny, the lowlands and southern Cascades. So it'll be a pretty decent day overall. The long-term trend, 6 to 10 day and 8 to 14 is looking like above average precipitation. So this time of year, that means pretty wet.
Yeah. And I like thinking about that and like the chance for more atmospheric rivers coming up. Like we'll have that mild one. It's not going to be super, super rainy this weekend, but after that one, we're looking towards like later next week, we might have some heavier ones and a decent amount of rainfall coming in. And right now, this is looking at the drought monitor for Washington State. And, you might look outside and you might think, how could it possibly be in a drought? Like, the rivers are flowing pretty well. Things are dripping, the forest is wet. But this drought monitor kind of highlights things that are longer term. And if we look longer term, we actually have been quite dry over in the state and in the Cascades. So this is our 6 month. If we look over the last 6 months, you can see that in general, anywhere like the lowlands and the Cascades have only seen about 50 to maybe 80% of normal snowfall. So in general, it's been pretty dry, but that's not a super wet time of year. Going May, June, July, August, September, even October are relatively dry months. So if we go out a year, we can see that this trend continues. And even if we go out 3 years, we can see that over the last 3 years, we've been relatively dry. We haven't really had a wet year since kind of 2021. So it'll be interesting to see what happens kind of in the next couple weeks, but also the coming months to see whether we end up kind of breaking out of this drought. And it's not super important for some things, like the rivers will recharge all the time, but we haven't had a really great snow year in the Cascades, especially the North Cascades, for a number of years. And in terms of groundwater, in terms of vegetation, all of those really rely on the amount of rainfall we receive each year. So maybe this year will be one of those wet years again, where we kind of recharge that and kind of break our drought habits of the last couple of years.
Well, thanks, Wyatt, and we hope you guys found this video interesting and have a great weekend.